Hi everyone, and welcome to this video on negative exponents. Let's begin. In this video, we will endeavor to answer 4 questions. First, we want to know, why do negative exponents exist in the first place? Do negative exponents result in negative numbers? What does a negative exponent mean? And how can we rewrite a negative exponent using only positive exponents? Let's get started. First of all, why do negative exponents exist? And the answer, or one answer, is that negative exponents can occur as a natural result of applying the quotient rule. So let me show you what I mean. Let's suppose that I have 2 to the third power divided by 2 to the fourth power. Remember, this is a problem where you can rewrite your exponents as a multiplication problem. So remember, 2 to the third power is 2 times 2 times 2. And 2 to the fourth power, right, would be 2 times 2 times 2 times 2. So we could look at it this way as a multiplication problem, but remember we also have a shortcut, and the quotient rule says when we divide two terms that have the same base, then we can subtract their exponents. So we would have 2 to the 3 minus 4 power, and that gives us 2 to the negative first power. Okay? So already, just by applying the quotient rule to this expression, we have a negative exponent. Okay? So again, as you can see here, it says if the power of the denominator, right, in this case the power of the denominator is 4, is greater than the power of the numerator, here it's 3, then you're going to end up, when you subtract, you're going to get a negative number. So let's see what this means when we actually do the multiplication and start canceling out terms. So hopefully you can see that these 2's cancel out, these 2's cancel out, and these 2's cancel out. So what's left? What's left over? Well, remember, even though it's kind of invisible, you could always put a 1 on the top. So this is actually equal to 1/2, or 1 over 2. So we've just proven that 2 to the negative 1 power is equal to 1 over 2. Okay? Another way to think about this is 1 over 2 to the first power. Okay? And so this is the general idea or concept behind negative exponents. So if I have 2 to the negative first power, that's going to become 1 over 2 to the positive first power. Okay? So again, the reason negative exponents exist is because they are a natural result of applying the quotient rule. So let's look at the next question. The question is, does a negative exponent result in a negative number? So we just said in our previous example that 2 to the negative first power is equal to 1 over 2. Is 1/2 a negative number? The answer is absolutely not. 1/2 is a positive number. 1/2 is greater than 0. So one way to start understanding the pattern that emerges with negative exponents is to use what's called a log scale or a logarithm scale. Okay, so let's start here with, in the middle, I like to put 2 to the 0 power. So remember, anything to the 0 power except for 0 itself is 1. So then let's say I have 2 to the first power. Well, 2 to the first power is 2. Then I could have, let's say I have 2 to the second power. That's 4. 2 to the third power is 8. 2 to the fourth power is 16. Okay? So the reason this is called a logarithm scale instead of a linear scale is because if you measured or if you counted the distance, right, between each step, it's not consistent. So in other words, 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8, 8 plus 8 is 16. In other words, since I'm using a base 2, it's doubling every time. Okay, so again, this is not a linear scale, this is a log scale. Okay, but the reason that this is useful to introduce at this point is because it helps us to start understanding the pattern of what happens when we go the other way, when we start introducing a negative exponent. Okay, so this is, remember, 1 over 2. Well, what happens if I have 2 to the negative second power? Well, if I follow this pattern, then the pattern suggests that 2 to the negative second power would be equal to 1 over 2 to the positive second power. let's see if I can prove this to myself. So, for example, let's say I have 2 squared divided by 2 to the 4th power. So if I write this out as a multiplication problem, I would have 2 times 2 on the top, and I would have 1, 2, 3, 4 2's on the bottom. Okay, and again, these 2's cancel out, and we're left with 1 over 2 times 2, or 1 over 2 squared, and of course that equals 1/4. Okay, if I had applied the quotient rule, 2 minus 4 is -2. So I've just proven to myself that 2 to the -2 is 1 over 2 squared, or I could write it as 1 over 4. Okay, if we keep going backwards on this number line, 2 to the -3rd, that's going to be 1 over 2 to the 3rd power, or 1 over 8. Then 2 to the -4th power is going to be 1 over 2 to the 4th power, or 1 over 16. Okay, so let's use this scale to answer the question, does a negative exponent ever result in a negative number? Okay, and the answer here, okay, is no, as long as you have a positive base. Okay, so our base here is 2. Okay, so if you have a positive base, okay, then our negative exponent is not making our whole number negative. But what is it doing to our number? Let's see if we can see a pattern. 1/2, 1/4, 1/8, 1/16. What's happening to those numbers? Well, the truth is that they're getting smaller and smaller and smaller. They're getting closer and closer to 0, but they're never going to drop below 0. Let's go on and ask or answer another question about negative exponents. So the next question is, what does a negative exponent mean? So now we can start thinking about a more formal definition. So up until this point, I've just actually been using numbers. 2 to the -1st power is 1 over 2. So let's switch to a variable rather than a number. So what if I have a to the -1st power? What does that mean? Well, that means 1 over a. Okay, but what if it's not -1? What if it's -2? Well, that's 1 over a squared. So is there any way to generalize this pattern? And there absolutely is. So if I say a to the -nth power, I know that is going to be 1 over a to the nth power. Okay, so that is the definition of a negative exponent. Again, a to the -nth power, where n is going to be equal to a positive integer or whole number. A to the -nth power is 1 over a to the n. Okay. The other thing that you need to know is that if I start with a to the -nth power on the bottom, okay, the way I make that positive is that I bring it upstairs. Okay, so these are also equal to each other. Okay, another way to prove this, another way to demonstrate the truth of this, is that this is actually a fraction. It's a proportion that I could cross multiply. So I would have 1 times 1 is equal to a to the nth power times a to the -nth power. So remember, the product rule says that I can add exponents when I'm multiplying by the same base. N minus n is equal to 0. So I also have this definition that emerges that 1 is equal to a to the 0 power. And remember, that's true of all numbers as long as the base itself, a, is not equal to 0. Okay, let's answer our last question. Okay, how can we rewrite a negative exponent using only positive exponents? So, for example, let's say I have this problem. Let's say I have 5a to the -3rd, b to the 5th, c to the -7th, divided by d to the 7th, e to the -6th power. Okay, so anything that is just a coefficient like 5, okay, does not need to change. It can stay exactly where it is. Again, anything that has positive exponents like the b, right, b to the 5th power can stay exactly where it is. D to the 7th power can stay exactly where it is, which is downstairs. right? So the only things that have to change here are the negative exponents. Okay, so if I look at a to the negative third, in order to make that exponent positive, I have to bring it downstairs. Okay, then the c to the negative seventh, again, to make that exponent positive, it needs to come downstairs. And lastly, e to the negative sixth, in order to make it positive, it needs to go upstairs. Okay, so this would be my final answer using only positive exponents. Let's make up another example. So let's say I have a to the negative sixth power, b to the negative seventh power over 4a to the fourth power. Well, one thing that's different about this example is that I have two a's here. So what I would like to do is I would like to apply any rules, product, quotient, or power rule first, and then at the end I want to rewrite everything using positive exponents. Another thing that often confuses people is what happens to this 4. And it's important to understand that the 4 does not belong to the a that it's next to. It's just its own number. There is no exponent above the 4 or next to the 4. So it just stays exactly where it is. Do not move it. Do not move it into the denominator. Don't change it. Just leave it alone. Okay? So what I'm going to do is I'm going to apply the quotient rule with these two a's. Remember, the quotient rule says that we subtract exponents when we divide. So we're going to get something that looks like that. A to the negative 6 minus 4, and then b to the negative 7th is still there. Notice I'm not addressing the fact that I have negative exponents yet. I'm first applying the product, quotient, or power rule as appropriate before I change or bother with the negative exponents. So negative 6 minus 4 is negative 10. Then I have b to the negative 7th power, and then I have 4 in the denominator. So in order to make these exponents positive, they need to all come downstairs. The 4 is the coefficient, so it needs to be in front. This becomes 4a to the 10th, b to the 7th. Now we have a problem here because these are all in the denominator, but as you can see, since we moved everything to the denominator, nothing's left upstairs. So what can we put there? Well, remember, there's always a 1 here, right? 1 is always your coefficient. So what I would do is I would write a 1 upstairs as my numerator, and so this would be the final answer. So hopefully after watching this video, you can answer those 4 questions. What is a negative exponent? How can we rewrite negative exponents using only positive exponents? Why do negative exponents exist? And do negative exponents ever result in negative numbers?